Hey guys, Mr. Kyle, Myers Mathematics, and let's just jump right into it. So today I want to talk about power rules, not powers rule, but powers do rule as far as superpowers go, right? But how to remember them. So I'm going to show you how to remember them, just the easy way to remember all the different rules, and then also just give you a bunch of examples with how to use them. So let's talk about one rule at a time and do an example of each, and then I'll put some more examples on the end here. But so one of the rules is that when you multiply, and I'm going to be really like I'm not going to use a lot of technical language here, so it's not going to be like super correct what I'm writing here, but it's basically what's happening. So when you multiply, you add powers. All right, so for example, let's say I have like x squared times x3, x2, x3. I don't always say squared or cubed or to the power of, I just say the number. But x squared times x cubed, it looks like I'm timesing, but I'm not timesing, I'm going to add. I'm going to add the powers, keep the x's the same. Right? So another rule is when you multiply, or sorry, not multiply, when you take a power to a power, you multiply. So for instance, let's say I have x squared to the third power, right? So now I'm going to multiply the powers. Instead of taking 2 to the third power, I just do 2 times 3, which is 6. Right? So 2 more rules. When you divide powers, or I should say when you divide, you subtract powers. So here, if we have, I'm just going to keep using the 6 and the 3s and 2s and stuff. If I do 6 and then a 3, let's do a 2 instead. If I do a 2, then this would be x to the 6 minus x to the 2. So 6 minus 2 is 4. And then last rule, when you root, right? So for example, square root, right, which is that sign. When you root, you divide powers. So for example, let's say I have the square root, which by the way means that there's a little 2 there, right? You don't have to write the 2, but it means there's a 2 there. X to the 6. So that would mean x to the 6, right? So 6 divided by 3 is, 6 divided by 2 is 3. So when I root, I divide the powers, divide the power inside by the little number that goes here. If there's no number, it's a 2. Right? So those are the 4 basic rules of powers. As far as like putting them all together and stuff, there's other ones too. Like for instance, x to the 0 power equals 1, right? So anything to the 0 power equals 1. X to the 1 equals x, right? If you have no power listed, then it's just a 1 power. 0 to any power is 0. 1 to any power is 1, right? There's a couple other stuff like that. This first one probably makes the least amount of sense out of all of them, but I'll probably make another video on that one. I want to focus on these guys in black and green here. So there's a way to remember all 4 of these without really needing to remember each one individually. And that's because there's a pattern here. The pattern is, if you think about adding, right? So if I add a bunch of stuff together, right? So adding is like, 2 plus 3. Now, if I said 2 plus 2 plus 2, that's 2 times 3. So that's multiplying. Right? So multiplying is a step up from adding. It's a step up. And then if I said 2 times 2 times 2, that would be 2 to the third power. So then that means that if I go a step up from multiplying, that's powers. Right? And then you can actually do the same thing for roots. So let's use red maybe, because usually roots and dividing and all that, it makes the number smaller. So let's use red to show that it gets smaller. So subtracting, opposite of adding. Right? So if you subtract over and over and over again, I won't show you examples for this one, but basically it's kind of like the same thing as dividing. So divide. And then and if you were to divide over and over again, that would be basically like a root. Roots, aka stuff like this, right? So here's how you remember all these rules. Let's look at the first one. When you multiply, you add the powers. So look, if you multiply, you add the powers. Next one, if you take a power to a power, you multiply. So if you take a power to a power, you multiply. So notice the pattern here is that we're stepping down. Let's look at the next one. If you divide, you subtract powers. Right? So what would that mean? That would mean dividing leads to subtracting the powers. And then last one, roots. When you square root, cube root, something like that, you divide the powers. So the rule here that you can remember, this is much easier than remembering 4 different rules. The basic rule here, and I'll just write it in a text field here, is that whatever it looks like you should do, go 1 step down from that. You want to step it down, right? So the way to remember this, and I'll make this bigger here. Let's increase this text so it's a little easier to see. And change to Times New Roman just because I like it better. Let's increase it to like 18 maybe. Yeah, that should be plenty. Right? So whatever it looks like you should do, go 1 step down from that. The way to remember this is actually really cool. What you can do is you can say, you can pretend like the powers and roots, right? Because roots are little numbers as well. Because you put a little number inside the root, right? This little number right here. Right? Baby number. It's still a baby number. It's still a smaller number than a regular number. So pretend like the powers and roots are little numbers, right? That's literally what they are. So, numbers. Or like baby numbers or kid numbers, right? Kid numbers. So the rule then becomes that kids are too little, or I should say kid numbers. Kid numbers are too little to do big number stuff. So that means that like if the kid numbers were trying to do powers, then you would multiply instead, right? They're trying to do powers, so already these little kid numbers are ahead of their game here. So they can probably just handle multiply, but they're too little to handle powers, right? Or if the kid numbers are trying to do multiply, you're too little, just do adding instead. Right, so that's one way to help remember it. So to imagine, like if you have a little brother or a little sister, imagine them, and imagine you're at like a theme park, like a Six Flags, or in my area we have like Busch Gardens, Disney. Imagine you're at a theme park. Your little brother or little sister might not be able to ride all the rides yet, right? They have to ride the kid rides, so they're too little, right? They're too little. You got to step it down. Instead of riding the big roller coasters that go upside down 1,000,000 times and go like 90 miles an hour, they have to ride the little kiddie ones that just, go like an easy 20 miles an hour and just kind of go around, and all the cars are shaped like teacups or little Disney things, or whatever. So imagine that in your head. Imagine like your younger sibling, or if you don't have one, pretend you do for a second. Imagine your younger sibling is at the theme park, and they can't ride the same rides as you. You have to step it down for them, right? So that's exactly how you remember the rules for powers. You want to step it down. Whatever it looks like you're supposed to do, step it down. They're too little. All right, so let's look at some more examples. All right, let's say I have, let's go to my drawing tools here. So let's do a little bit more complicated of an example. Let's say x squared y cubed squared. Okay, so this is power to a power, right? The powers are trying to do powers. This is powers, right? They're not being multiplied. That's not 3 times 2. That's not 3 plus 2. That's 3 to the second power. So first things first, whenever you have a 2, you distribute it. So this 2 goes here and here. But since I'm distributing it, it's going to be multiplied by both of those numbers. So this is x to the 2 times 2 power times y to the 3 times 2 power. And then that's x to the 4th power times y to the 6th power. Okay? So let's look at another one. Let's say we have x to the 3rd power times x squared all to the 5th power. Okay? So this is actually one of those examples of PEMDAS. You want to do the stuff in the parentheses first if you can before you do the power. So we could distribute the power like we did in the blue example, but since we can combine the x's, let's do that first. So power times a power, right? I'm timesing. So instead, baby numbers, kid numbers, they're too little. You're going to add instead. You're too little to times. 3 plus 2 is 5. Then this is x5, still to the 5th power outside the parentheses. Power to a power, so I multiply. They can't handle it. They're too little. So I do 5 times 5, which is x to the 25th power, right? So if x is like pretty much any number bigger than 1, this would be a really big number, right? 2, even 2 would be like 2 times 2 times 2 times 2 times 2, 25 times. So this is going to be a really big number. If x is like 2 or greater, huge number. Just for some context there. Let's do another one. Let's do some roots. So let's say I have the cube root of a squared b to the 6th power. So if I do power and then root, if I have a root, then I divide it. If I divide it, that means I take a to the 2 over 3. It's okay to have a fraction power. And then b to the 6 over 3. That I can simplify a little bit. The a I can't, because 2/3 is just 2/3. So 2/3. But b I can simplify. That's 6 over 3 is 2. So that's a to the 2/3 times b squared. Right? Let's do another one. Let's say we've got the 4th root of x to the 3rd power times x to the 5th power. Okay, this one's going to work out a little nicer. So now, again, PEMDAS, right? So this is like kind of inside of parentheses. Technically, the P for parentheses actually stands for any kind of like grouping, which is why a lot of people say GEMDAS. I don't know if you've heard that term, GEMDAS. I actually put a video out about that a while back, but GEMDAS is actually more accurate because anytime you're grouping stuff, that goes first. So let's put these guys together. It looks like I'm timesing, so the kid numbers can't do that though, they're too little. So we add instead, x to the 8th power, right? But I still take the 4th root, So then x to the 8th power, 4th root, if I have a root, then I divide the powers. I divide the exponents, I should say, because 4 is an exponent and 8 is an exponent. Those are both exponent numbers. They're just different kinds. Powers and roots are both exponents. So anyways, I would do 8 divided by 4. So this is x to the 8 divided by 4 power. 8 over 4 is 2. So this is x squared. And there we go. All right. I think I've done pretty much all of them except for division. Let's do one on division. So let's say we've got one on division. Let's say we've got 16 x squared y cubed z over 4 x y to the 6th power z squared. Okay, this is really crazy, right? We'll probably end with this one today. So let's just take it step by step. Anytime you have a big problem, don't let it overwhelm you. You've got to do what's called compartmentalizing, which means you take it one step at a time. Anything that takes a long time to do, you can't let it drag you down. If it's something important, you want to get it done eventually, but you don't have to get it all done at one time. So here, we don't have to get this all done at once, right? This is not a one-step problem. Just take it one step at a time. So we're going to do this first. We're going to do this first. Let's focus on this. Just focus on the numbers. What's 16 divided by 4? Yeah, 4, right? So just 4. Right? Pretty easy so far. Okay, now let's do the x's. This is x squared over x. So this would be a 1 power, right? Anything that doesn't have a power actually has a 1 power. So that would be x squared over x to the first power. If I divide, powers are too little to divide, subtract instead. 2 minus 1 is 1, so that's x to the first power. Now I don't have to write the 1 power, but I just figured I would. And then y's. So write the y's next. So this one's going to be kind of interesting actually, because I'm going to subtract again. Right? These are all being divided, so I'm going to subtract. But 3 minus 6 is actually negative 3. So we're going to talk about that in a second. But then let's do one more. So we got the z next. I'm going to use a rainbow color here. So z, that's the last one that we're going to do. And then this is z1, right? If it doesn't have a power, it's a 1. 1 minus 2 is negative 1. So z to the negative 1 power. Now, a lot of times, they don't want you to write the answer like this. So this would be fine, normally. Like, I would be okay with this. Like, if you were my student, I would be fine if you wrote it like this. But a lot of textbooks and a lot of teachers don't want you to have negative powers. Right? No negative powers. No negative powers. Right? And this is your teacher talking here. They've got a marker in one hand here, and they've got the blackboard behind them. This is the blackboard behind them, or whiteboard, whatever. Right? 3 plus 3 equals fish. So that's your teacher, right? No negative powers. A lot of teachers do this, so it's likely that yours is, so I want to address this. If you're not allowed to have negative powers, here's what you do with it. So negative power, right? Just move it. Just move it. Right? So what that means is you either move it from the top to the bottom, right? Numerator and denominator, if you want to use the math terms. Either you move it from the top to the bottom or the bottom to the top. Now, all of this stuff is technically on the top. So it would be 4x1 y to the negative 3 z negative 1 over 1, if you wanted to write it as a fraction. So just move it to the bottom. So I would have 4x, those are all positive, so they stay on the top. And then on the bottom, now this is y positive 3, z positive 1. And that would be my final answer if your teacher wants you to have no negative powers. All right, so that's what I had for today. Hope that was helpful. If it was, give it a like. If you want to see more videos like this, go ahead and subscribe to my channel. I've got a free resource, The 5 Math Mistakes Everyone Makes and How to Avoid Them. You can download that on my website, myersmathematics.com, and I hope to see you in another episode.